We can look at paraxial refraction by a spherical surface. Now, paraxial rays are light rays almost parallel to the optical axis. Okay, right now we have a point source. We arbitrarily take a light ray going in this direction, and it hits the spherical surface at this point. Now, this line comes from the center of curvature. So in other words, alpha is the incident angle, and beta is the refraction angle. And the reflected light comes down, intersect with the optical axis, and that locates the image. Now we're going to define this angle called gamma. So gamma plus beta is equal to this angle. And this angle plus this angle is equal to alpha. So this angle is alpha minus beta minus gamma. And we're going to relate all these defined variables in the following way. The first one is Snell's law. N1 sine alpha equals N2 sine beta. Now we apply the paraxial approximation. That means the angle very small. That means we move this point down here, very small. So N1 is times alpha equals N2 beta. Now we take the tangent of gamma equal d over this distance, and we apply the approximation. Tangent gamma is gamma. When this angle is very, very small, the adjacent line is q, the image distance. Now we take tangent of this angle, which is d over this line. If we apply the approximation for a small angle, the adjacent line here is the radius of curvature. Now we take tangent of this angle, and we apply the approximation. The adjacent line is now P. And we're going to work on this four equation. The first thing we're going to do is we add equation 3 to equation 4. When we add equation 3 plus equation 4, we get the equation for alpha. Now this is equation 2. This is equation 3. We're going to plug gamma into here, and we get an equation for beta. Now we look at Snell's law. N1 times alpha equals N2 times beta. So we multiply this equation by N1, and that is equal to this equation times N2. So we get this equation, and we rearrange it and get a very useful equation indicating the refraction by a spherical surface. The equation related all the parameters given in the problem.